Okay, guys, welcome back. We're going to be solving another question from the chapter 4 of Engineering Mechanics by Meriam. And in this one, we have a dual grip clamp that is shown in the figure, and it's used to provide clamping force with a positive action. And we know the vertical screw is tightened to produce a clamping force of 3 kilonewtons. So the force that is applying from this vertical screw, if you just want to draw the free body diagram for this part of this clamp, this force is going to be 3 kilonewtons, and the horizontal screw is also tightened, this one in here, until the force in the screw at 8 is doubled. So we're looking for getting to a point that the force in this member, you call it maybe F, is doubled. But first of all, we need to figure out what's that force for this 3 kilonewtons. And after that, we're going to see uh, if that F is doubled, what force P we're going to have in here. And the question is asking us to find the total reaction R at pin B. So we're going to call it the two components in here, Rx, Ry. And at the end, we need to find the resultant of these two, which is going to be the R that the question is asking. And yeah, that's pretty much it. So let's start with the first part where our clamping force is 3 kilonewtons. And based on that, we're going to find the force F. So the easiest way, obviously we are in equilibrium, 3 equations, sum of all forces in X, Y, and you can have one moment equation. So it makes sense here to start our moment equation about point B, counterclockwise positive. That way we can find the force F that we have. So we're going to have the moment of the 3 kilonewtons. First of all, the moment is going to be clockwise, so minus 3 times the vertical distance from B to the line of action, which is 75. All the dimensions are in millimeter, but we don't need to do the unit conversion to meter because it will be canceled out at the end. And also we're going to have the moment of the F, which is a counterclockwise moment, so positive F times, again, the vertical distance from B to the line of action, 125 equals 0. And here we should be able to find F pretty easy. 3 times 75 divided by 125. Let's see what we get. 3 times 75 divided by 125. This is going to give us 1.8. And the unit will be kilonewtons. And now we're going to go to the second part of the question where the horizontal screw is tightened until the force in the screw is doubled. So now we are going with the F twice as that size, 1.8, which is going to be 3.6 kilonewtons. All right, now that the F is doubled, we have to find the new force that we're going to have in here. And that's going to be double too because of, again, our moment equation that we did in the previous step. If we have our force F doubled, obviously our P has to be doubled too, just to satisfy this equation. So the new force that we have in here would be 6 kilonewtons. Now for finding Rx and Ry, we just need to do our Fx and Fy equations. Pretty easy, we can find both. So sum of all forces in X equals 0, we're going to have Rx minus the horizontal force F, which was 3.6 equals 0. So Rx is 3.6 kilonewtons. And last one would be sum of all forces in Y. We're going to have the 6 kilonewton upward, so 6. We consider upward the Ry also upward, so plus. That shows that the direction for Ry is not correct. We're going to get minus 6 kilonewtons. That shows Ry is downward, but Rx was correct. And if we want to find the total reaction, we need to find the resultant, which is basically square root of Rx squared plus Ry squared. Let's see what we get. So square root of 6 squared plus 3.6 squared. And that's going to give us a value pretty close to 7 kilonewtons. And the final answer for this question. So one thing that you need to keep in mind, and probably the trickiest part of this question, when this force is doubled, the force that is applying vertically also will be doubled. So you just have to watch for that in here, because if you do 3 by mistake instead of 6, you're going to get a different answer. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.